So this extension we're going to talk about special right triangles. So there's two types of right triangles that are special in the world of geometry. They are known as 45, 45, 90 right triangles and 30, 60, 90 right triangles. They can be used as shortcuts instead of using the Pythagorean theorem. And they help us find missing sides of right triangles. So we're first going to explore that 45, 45, 90 triangle first. A right triangle is isosceles only if it is a 45, 45, 90 triangle. The legs are congruent, and the length of the hypotenuse is the square root of 2 times the length of legs. And that is true every single time. Every time you have an isosceles right triangle, the legs are the same. That's what makes it isosceles. And the hypotenuse will always be whatever the length of the leg is times radical 2. That is true every single time you have an isosceles right triangle. Okay, that's why we can use it as a shortcut. So, what we can do is use this fact to help us find missing sides of a right triangle. So, we want to find the values of these missing variables, x and y. We're going to round our answers to the nearest 10th. Back in the olden days, we had to keep everything in radical form. But right now, let's just focus on getting these rules down. We're not going to really worry about the radicals as much. So we're just going to round all of our answers. So, I know this. First, you have to make sure it is a 45, 45, 90 right triangle. And we know it's a 45, 45, 90 right triangle because it's isosceles. And whenever you have an isosceles right triangle, those acute angles are always 45 degrees. So we're going to use that rule. And on the green reference sheets I give you, it has the rules for these special right triangles. So this is one of the triangles on your green formula sheet. You can use that to help you. So if I look at my reference sheet, it's showing me that the legs are the same. They both have an x. So this leg is 15. That leg is also going to be 15. Then they take whatever my leg is and they multiply it by radical 2. So I'm going to take my leg length, which is 15, and also multiply that by radical 2. And let's plug it in our calculator. We're going to do 15 times radical 2. If we round that to the nearest 10th, it's about 21.2. So there you go. My x is 15, and my y is 21.2. My answers. A lot faster than having to use the Pythagorean theorem to find that answer. A little shortcut. You can also think I'm going from small to big. I went from a leg to a hypotenuse. I'm going from small to big. So I multiply. Here, we are given the hypotenuse, and we want to know the lengths of our legs. We'll think I'm going from big to small. Okay, so if I look at my hypotenuse here, my diagram, I have x times radical 2. So when I go to my leg, the radical 2 is no longer there. Well, to cancel it out, we have to divide. So we went from big to small. So instead of multiplying by radical 2, we are going to divide by radical 2. So we're going to do 22 divided by radical 2 and see what we get. To get the radical, second x squared, and it gives us that. Round to the nearest 10, so it's about 15.6. So the legs are the same. So y is 15.6 and x is 15.6. And those are my answers. To do this using the Pythagorean theorem would have been very difficult. So just knowing this shortcut makes it easier. And again, you have to double check, make sure you have a 45, 45, 90. I know I do because I have, if one angle in a right triangle is 45 degrees, the other angle is automatically 45 degrees. So now, let's take a look at the 30, 60, 90 right triangle. All 30, 60, 90 right triangles are scalene. So you'll always have three different side lengths. You'll have a short side, a long side, and a hypotenuse. These sides are also related. The length of the hypotenuse is twice the length of the short leg. The length of the long leg is the square root of 3 times the length of the short leg. You always want to know the length of the short leg when dealing with 30, 60, 90 right triangles because it's easier to determine the other lengths if you know it. Right. So the short leg, something to keep in mind, the short leg is always the side that's across from the 30-degree angle. The long leg is always the side that's across from the 60-degree angle. And as we know, the hypotenuse is always the side across from the 90-degree angle. Something to keep in mind. Again, you have this diagram on your reference sheet, so use it to help you. Okay? We want to find the value of the missing variables. Round your answer to the nearest tenth if necessary. So we have to determine what we're given. I'm given this side. When I look in my diagram, it's the side that's across from the 30-degree angle. I'm given my short side. That is x in my diagram. Well, to get my hypotenuse, it's saying, hey, take your short leg and multiply it by 2. When we do that, we get 12. To get the long leg, the side across from the 60, again, it's saying, hey, take your short leg and multiply it by radical 3. So when we do that, 6 times radical 3 is about 10.4. So my answers are x is 12 and y is 10.4. There you go. So it's really easy. Once you know what your short leg is, all you do is just multiply. And then you do look at your diagram to determine what you're multiplying by. Okay. If we take a look at example 4, again, we're given a 30, 60, 90 right triangle. We know it's a 30, 60, 90 right triangle because we have a 30-degree angle and a 60-degree angle and a 90-degree angle. This time around, we're given our hypotenuse. And I know it's the hypotenuse because it's across from the 90-degree angle. Well, look at my diagram. I go from 2x, and you always want to find your short side first. You have to find your short side first. So we go from 2x to x. I'm going from big to small, so I'm going to divide. To divide, I have to get rid of this 2. So I'm going to divide it by 2 to get the small leg. Okay? So I'm going to do 18, and I know this is the short leg because it's across from the 30-degree angle. That's my short leg. So to get it, I'm going to divide my hypotenuse by 2 to get 9. Now that I know my short leg, when I look at my diagram, to go from short leg to long leg, I just multiply it by radical 3. So when I do 9 times radical 3, I get about 15.6. So A is 9 and B is 15.6. And there you go. And this last example, this time around again I have a 30, 60, 90 right triangle, but this time we're given the long leg. And I know I'm given the long leg because that's what's across from our 60-degree angle. So we look at the diagram, you always want to find your short leg first. So we're going to find this leg first because it's the one that's across from your 30-degree angle. You have to find that one first. So to go from long leg to short leg, we canceled out that radical 3. So that means we're dividing by radical 3. So I'm going to do 12 divided by radical 3. and that will give me my short leg. And that's about 6.9. So my short side is 6.9. Now that we know my short side, you just have to double it, have to multiply it by 2 to get your hypotenuse. And when we do that, 2 times 6.9 is 13.8. So M, my short side, is 6.9 roughly, and N is about 13.8. Here we go. So now, if you want to, you can pause the video and try these practice problems on your own. Okay, try these practice problems on your own. If you feel like you need to watch more examples, I'm going to go ahead and do these now. So you could either pause, try them on your own. The solutions are on the back, so you can check your work, or if you just feel like you need to watch more, you can. Okay, so when we look at this first one, okay, we have a 45, 45, 90. No, it's 45, 45, 90 because one angle is 45 degrees. And we can use this reference sheet. I'm going to bring it lower so I can reference it a little bit better. Okay. So we're going to look at the 45, 45, 90 right triangle to help us answer these questions. So I'm given a leg, and I know my legs are the same. So I know this is going to be 5 radical 2. To go from leg to hypotenuse, we multiply by radical 2. So I'm going to do 5 radical 2 times radical 2. So let's plug that in our calculator. 5 radical 2, make sure you arrow out, times radical 2. And that gives us 10. So x, our hypotenuse, is 10. My other leg, y, is 5 radical 2, which is, we forgot to type that in our calculator. You honestly can just leave it as 5 radical 2, because that answers 5 radical 2. And we actually want to round. So you can leave it as 5 radical 2, or you can plug it in your calculator. When it's given to you in radical form, because this says 5 radical 2, then that's okay for that answer to be 5 radical 2. It makes it a little bit easier. If it's confusing, just do 5 radical 2 in your calculator and just change it to 7.1. So you can just make that 7.1 and you can make that 7.1. Make that 7.1 if that is less confusing for you. Okay. So here if we look at B, I know I have a 45, 45, 90 right triangle. My legs are the same. This leg is radical 2, so that leg is going to be radical 2. To go from leg to hypotenuse, we multiply by radical 2. So I'm going to do radical 2 times radical 2, which gives us what? Radical 2 times radical 2 gives us 2. So y is radical 2. Again, if it's given to you as a radical, you can just leave it as a radical. And our x is 2. Here's our answers. If we take a look at C, this time we still have a 45, 45, 90, but we're given the hypotenuse. So we're going from big to small, hypotenuse to leg, we have to cancel out that radical 2. So we're going to divide by radical 2. So we're going to do 17 divided by radical 2. And we get about 12.0. So we get about 12. So I know my legs are the same. That is 12. That is roughly 12. So my M is about 12, and my N is about 12. Okay. Then if we look at some more, these are 30, 60, 90 right triangles. So we're going to use the 30, 60, 90 diagram. I know this is a 30, 60, 90 because I have a right angle. One angle 60, the other one is 30. Okay? And I'm given my short leg. So all I have to do is multiply my short leg. So I'm going from short leg to hypotenuse. I just double it. I multiply it by 2. 2 times 9 is 18. Then when I'm going from short leg to long leg, I multiply it by radical 3. So I just do 9 times radical 3. We do that in our calculator. 9 times radical 3 gives me 15.6. So x is 9, our hypotenuse, and y is 15.6, our long leg. Here we're given our hypotenuse. I know this is a 30, 60, 90 because I have a right angle and a 60 degree. The other one's automatically 30. I have the hypotenuse. I'm given the hypotenuse. I'm going from hypotenuse to short leg, so I have to cancel out that 2. So I'm going to divide it by 2. 18 divided by 2 is 9, so I know that leg here is 9. I know that's the short leg because that sits across from the 30-degree angle. Then to go from short leg to long leg, I multiply it by radical 3. So I'm going to do 9 times radical 3. And I get 15.6. There we go. So V is 9 and U is 15.6. Here we're going from, we are given our long leg, because I know that's 60 degrees, because again we have a 90 and a 30-degree angle, the other one's automatically 60. We're given the long leg because that's the side across from the 90-degree angle. So if we look at the diagram in the corner, we're going from long leg to short leg, we have to cancel out that radical 3. We have to divide that by radical 3. But we really don't even have to plug anything in our calculator. Because we divide by radical 3, they cancel out, we're just left with 8. So my short leg is 8. You could have plugged it in your calculator, you still would have gotten 8. So now that we know my short leg, to go from short leg to hypotenuse, we just double it. We multiply it by 2. So my hypotenuse is 16. So y is 8 and x is 16. We take a look at these last examples. It's more jumbled this time around. Again, I know this is the 30, 60, 90 because we have a right angle, 30 degrees. I'm given the hypotenuse, so I'm going to use this triangle down below. To go from hypotenuse to short, we have to cancel out that 2, so we divide by 2. So I do 9 divided by 2, which is 4.5. So my short leg across from the 30 is 4.5. To go from short leg to long leg, we multiply it by radical 3. So my calculator, I'm going to do 4.5 times radical 3. And we get about 7.8. Go from short to long, you multiply it by radical 3, and that gives us about 7.8. You can just leave it right next to the 6. This one's a little bit of a trickier one. I know I have a 45, 45, 90 right triangle. One angle's 45, one's the right angle, the other one has to be 45 degrees. Well, I know my legs are the same, so it's okay. If you're given radical form of a leg, it's okay to leave it in radical form. You don't have to change it to a decimal. Totally fine to leave it like that. Makes your life easier. But if we look here, to go from leg to hypotenuse, we have to multiply it by radical 2. So let's plug that in our calculator. I like to use that alpha y equals button. 3 radical 2 over 2, arrow out, times radical 2. And we get 3. That's all that stuff to get that nice little number, 3. So my one leg is 3 radical 2 over 2, and our hypotenuse is 3. Last one here, it's a 30, 60, 90. One's the right, one's 60, the other one's 30. We're given the short leg. So again, we're going to use the 30, 60, 90 triangle down here in the corner. When I'm given the short leg, to get the hypotenuse, I multiply it by 2. And again, I know I'm given the short leg because it's what's across from the 30. So I'm going to multiply it by 2 to get the hypotenuse. So in my calculator, I'm going to do, again, the alpha y equals green button, 4 radical 3. Oh, calculator's doing weird things. 4 radical 3 over 3 times 2. Sorry, that was multiplying. And that gives us about 4.6. So our hypotenuse is about 4.6. Then we go back to the short leg. To go from short leg to long leg, we multiply it by radical 3. So I'm going to do 4 radical 3 over 3 times radical 3. Let's see what we get. So alpha y equals, enter, 4 radical 3 over 3, arrow out, times radical 3. And that gives us, again, all those radicals, we get a nice number, 4. So U is about 4.6, and V is 4. So there you go. If you need to, watch the video again. If not, there's some more paper practice that you can work on.